So on the bottom of the front page of your packet, I want you to get your learning goals down, okay, and your title and your page numbers for reference there. Okay, so graphing square root functions today. So let's go ahead and take a look at the front page of the packet. What I want you to do right now with your group, or the people, if you're just sitting with one person, find someone to work with, okay, or turn and work with someone. Okay, I want you to fill out this table for this graph the best you can, just based on what you know about filling out tables. Fill out that table for that graph. There you go. Okay, so what were some of the problems you came up with? Amanda?
You had to, like, if you just did, like, 1, 2, 3 or something, it would work. So you had to find out what could be root, what square roots had a whole number.
Okay, yeah, so how many of you chose like 1, 2, 3, 4, 5? Did anyone just put 0 here? Yeah, most of us, right? Because that's what we do. That's what we've done in the past. Now, I'm not saying that that's what we should do, but if we go with that logic, which we've done in the past, it's all right. So we put that in, and when you put 0 in, what is the root of 0? 0. Yeah.
I did that wrong.
Okay? And so just follow along right now. Logically, then what goes here? 1. And what's the root of 1? 1. So really pretty good so far. Now, as Amanda was saying, if we put 2 in, how many put 2 there? Now, how many got a nice, pretty whole number? What's the root of 2?
Like 1.3 something?
Yeah, it's 1 point something, 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 right? And it's okay to do that. But if we put 2 there, we get a decimal. What would be the next number we could put there to get a whole number?
4.
Yeah, 4. Why 4? Hey, hold on. Raise your hand. Why 4? Emily? Yeah, it's a perfect square. So we're trying to make those perfect squares. So that makes this now a 4. And the root of 4 is? 2. What would I put here then? 9. The next perfect square, root of 9 is? 3. Now, you could use 2 and 3 and 5, but you're going to get decimals. Now, what number do we put here?
-1.
If we put -1 there, what's the square root of -1?
No solution. It's actually 1. Is it? No? That's maybe.
Square root of -1?
You can't square a negative.
Brina?
I thought you could, like, square a negative.
Yeah, you can't take the square root of a negative. Yeah, that's what Charlie's saying too. You can't take the square root of a negative, so this is undefined. If you did that on your calculator, it'd give you an error. Okay? So all these negatives up here, these really aren't going to matter. So did we have to skip all the way down to here? No, we could have probably started our table there, make our 0. Okay, that's okay. And so if we graph it, let's go ahead and graph it. We have 0, 0. We have 1, 1. We have 4, 2. And we have 9, 3.
It's pretty looking.
It's pretty cool looking.
It's a little weird looking.
It almost looks like half of a parabola that's been tipped over, right? I mean, if I kind of filled in the other part,
You can't. It's about.
it'd be like that, right? And then you'd see our parabola. It's like so we had our parabola, and we just tipped it over. Everyone see that?
Cool.
It's called an inverse function. It's the inverse of a parabola. You guys will study that a little more in advanced algebra. But it's where you reflect it across the y equals x line. That's not really important right now. But why wouldn't this be a function if I had this other part right here? Studied it a bit earlier in the year. Had to do with these types of lines. Oh, can't remember. Well, this is not part of our graph, but let me just kind of sketch that in there. There were a couple rules when we said when we said that an equation was a function. Yeah, it has to pass the vertical line test. How many remember the vertical line test? Okay, so if we have this bottom piece, that's not a function. And that's actually, if I put in the bottom part, that's the negative portion of that. So if I were to graph plus minus the root of x, that would be both branches there. When I'm graphing just the positive part of x, it opens upward. And that's the positive part of root x. Okay, so that's what we wanted. That's what we graphed. Now, is this a function? Does this pass the vertical line test?
Yes.
Yep. Good. So we've got a function there. Yeah. Okay, well, let's talk about the domain. What does domain mean?
I don't remember.
Yeah, you got it. What was it?
X.
X. Domain means x. So where does this graph exist on our x-axis? Does it exist here? Everyone tell me when to stop once we get to the graph.
Stop. Right there.
Starts right here at 0. And then it is getting bigger or smaller from there?
Bigger.
Are we going, we're going towards the positives on x. So it's getting bigger. So x has to be greater than, can it be equal to 0?
Yes. That's greater than or equal to 0.
How do you know it's equal to 0?
It's on 0.
Yeah, it's on 0. There's a point on 0, right? So it's greater than or equal to 0. That is our domain. Our range deals with what? Y. So we start here, and we start going up the y-axis. Where does it start at? 0. Does it exist at 0? Yeah. So it's at 0. So y is, so from there, it's equal to and greater than. You're going up still, okay? Y is greater than or equal to 0. Okay, one more thing that we haven't talked about, and this is kind of foreshadowing what we're going to be getting into. So pay close attention to this. Everyone tell your neighbor what I am adding outside of my radical. What's outside here?
Plus.
Plus what? Tell your neighbor real quick. Okay, what number's out here?
Uno. 0.
One's out here? Zero's out here? Okay, yeah, there's a 0 out here. Okay?
Then why did you?
All right? There's also a number inside the radical with x.
1.
What number's inside the radical with x?
Uno.
Okay, what are we adding to x? Not what's in front of x. What are we adding to x? Or subtracting from x? Yeah, 0. Nothing. That's why we don't show anything. That's why we're just saying y is equal to the root of x. Now that 0, 0 right there, and I really should have put minus. Okay, it doesn't matter for this problem, but it really should be minus. That 0, 0 right there, that shows up right here and here. It also shows up on my graph. Where does it show up on my graph at? Yeah.
Where's the line where they hit both the x and y?
Yeah, it shows up right here where it hits the x and y axis. It's actually the starting point of my graph, right? Okay, I know that doesn't mean a lot right now, but it's going to start meaning a lot. Okay, so I want you to mark that point. It's really important. It shows up right here. It's what we're adding there and there. And I'm going to give you an equation for that here in a while. But notice it shows up there. It shows up here. And it shows up right here. It shows up 3 different times. Any questions there? Okay, so to recap, what are we trying to make our square root be?
Whole number.
Yeah, trying to make them be square numbers. It was easy here because we just put in squares for x. Okay, let's turn the page. All right, take a look at number 1. It's not going to always be that easy. Okay? You're still trying to make square numbers right here. It's a little tougher though. So what are the squares we're trying to make? Well, what's the first perfect square?
Uno.
Nope.
That's not true. 0.
Let's go back. All right. You guys look at mine. What's the first one we're trying to make? Trying to make the root of 0. So we're trying to make 0 in the radical, which means, I look back here, I'm trying to make that x plus 3 become what? I'm trying to make it become 0. Okay? So you may want to make a note to this is your note page as well as your assignment here. Try to make this equal 0. And then what are we trying to make it equal? 1. And then what are we trying to make it equal?
4.
4. And then what are we trying to make it equal?
9.
9. Okay, so we want this root to equal 0. We want it to equal 1. We want it to equal 4. And we want it to equal 9. That means we need to figure out x plus what, or what plus 3 makes 0.
3, -3.
Yeah, we need to make x equal -3 there. So -3 plus 3 makes 0. How many are with me there? Okay, what's the root of 0? 0. Yeah. Okay, and then go ahead and fill out the next one. What plus 3 is going to make 1? Okay, volunteer. What plus 3 makes 1? Yeah.
Volunteers should be.
-2. And square root of 1 is? 1. Okay, everyone figure out the next two. What plus 3 makes 4? What plus 3 makes 9?
So confusing.
Not really, Peter. Pay attention.
No, I'm trying to.
So, for those of you struggling right here, you're trying to say x plus 3 equals that 4. So this piece has to equal 4.
Oh, okay.
And so if you solve that, what plus 3 makes 4? Well, 1. So x has to be, so that number has to be 1. So 1 plus 3 is 4. So the root of 4 is 2. And then if you're doing this one, for 9, you write that here. I want x plus 3, the thing in the radical, to equal 9. So what plus 3 makes 9?
6.
6. X equals 6. Okay? So that becomes 6, and this becomes 3. Okay? Then we're going to go ahead and graph them. Before we do that, are there any questions on how I did the table?
No. Not by me.
Okay, everyone rate yourselves 1 to 5. 5, you got the table. 1, you're struggling with it.
6.
Okay? All right, let's go ahead and check it out here. So we got -3, 0.
Should be a 1 meter.
-3 and 0. All right, -2, 1. We've got 1, 2. And we've got 6 and 3. Here's our curve. All right, remember on the last problem, I said let's focus on this number. I'm going to rewrite it here. Y is equal to the root of x plus 3. Hey, what are we subtracting from x here? We're adding, right? What made this 0? -3. That's our domain. X is greater than or equal to -3. Notice that's the x value of our vertex, of our point right here. What are we adding to the outside of this? Outside of the radical? 0. Well, notice that's the y value of our range. Y is greater than or equal to 0. There's that -3, 0, -3, 0, and -3, 0. All right. Any questions there? So the domain and range are always found back here, and we're going to keep talking about that as we go on. But it's that point, it's what makes this 0. Notice it's the opposite of what was here. It's -3. And then since it's getting bigger and bigger, it's greater than or equal to. Okay, try number 2.